Good evening. Let us discuss the MATLAB program for the generation of sinusoidal signals or sequence, discrete time sequence with normalized frequency 0.15, and let us work on sum of two sinusoidal sequences of normalized frequencies of 0.1 and 0.3. Also, we shall work on how to generate the product of the sinusoidal sequence of normalized frequencies of 0.15 and a real valued exponential sequence 0.8 power n, right? Hint: kindly make use of the sequence length of sequences to be, say for example, 51. Let's perform downsampling by a factor of 4. Let's plot the original and downsampled sequences, and also we shall change the downsampling factor through the MATLAB program. So the first command is CLC, and you know the use of clear all, close all. Yes, let me fix the length of the sequence is equal to 51, and small n is an array vector which starts from 0 and goes up to n minus 1. It is the time axis, time index. Let's generate three sequences. The first one is a very simple sinusoidal sequence with the sine of 2 pi, where 0.15 is its normalized frequency. So 2 pi fn, signal x1, sinusoidal sequence of normalized frequency 0.15. I have another one, sine of 2 asterisk pi asterisk is pi asterisk 0.1 is its normalized frequency, 2 pi f1 n is actually added with, right, sine of 2 asterisk pi asterisk 0.3. We create two sinusoids. We produce a sum of these two sinusoids. And yes, there is one more third sequence, which is the product of first sequence with 0.8 power n is its real valued exponential sequence. Third signal is a product of sinusoidal sequence with a normalized frequency 0.15 and a real exponential sequence, right? So we have created it. Now we shall go to the definition of downsampling by a factor of 4. Actually, if you look at the downsampling factor, we used to define it as d is equal to 4. I hope you would remember. Let me work with first downsampler with a function of downsample by a factor of 4. Take the first sequence, downsample it by a factor of 4, and let me calculate the length of the first sequence, length of y1. Yes, similarly y2, is a new sequence, which is actually a downsampled sequence, which takes the input of x2, which downsamples the input by a factor of d. Let me calculate the length of y2. Okay. Similarly, let me work with y3, which is equal to downsampling of a new sequence x3 by a factor of d, and let me produce L3 is equal to length of y3. Accepted? So let's plot all those signals. For example, I have figure of 1, new figure. Let me go for subplot of, for example, I just plan to create 5 segments, 3, 2, 1. Let me plot stem of 0, n minus 1 is the first x-axis, and we go for x1 of 1 colon n, only n samples of it. Let me produce the label also. What is the label? Y label. What is the label? We used to say it is x1 of n, isn't it? So x1 of n. If I put square bracket, I don't find any difficulty. You can give title. Similarly, you can go for subplot of SUB, subplot of 3, 2, 2. Let me go for stem of 0 colon, just fix n 0 colon n1, n minus 1 this axis, and we shall plot 1 colon n the second sequence. Similarly, we shall go for subplot of, or you can just take the one first part, you can just take the, because it will become a figure window of 3 rows by 5 columns, isn't it? 3 rows by 2 columns, I'm sorry. So in this, let's choose the first one and the third one, okay, or the fifth one to plot the sequence. Plot the original, okay. Similarly, the remaining locations could be chosen for plotting the downsampled sequence. But when you plot downsampled sequence, for example, I have subplot of 3, 2, 5, stem of, you can just take it as 0 colon n minus 1, comma x3 of 1 colon n. Sorry, last one is not necessary, it seems. You can just put a semicolon over here. Similarly, you can just think about plotting y1, plotting y2, and plotting y3 also. If you change the downsampling factor by 5 or 7 or 11 or 12, you can change the programs accordingly. Right? Is that clear to you? Thank you.